What's up guys, my name is Nishit Tarantula and today I'm gonna explain you about the photoelectric effect provided by Professor Albert Einstein, and this was his first paper on quantum physics in which he won his Nobel Prize. So let's start. Off with the photoelectric effect by Professor Albert Einstein, and I'm your Nishit Tarantula. Imagine it's you and I provided you a ball, and on the surface there's another ball. Let it be ball A and let it be ball B. If you apply some force to ball A, this ball will approach ball B with some kinetic energy, and that kinetic energy will be transferred to ball B. As you know, the law of conservation of energy, so the energy from ball A will be transferred to kinetic energy in ball B, and the ball B will get displaced. According to Sir Isaac Newton, light was a particle, and there was one more scientist, I don't remember his name. He said that light is a wave. It caused a confusion between scientists that what is light. So then Einstein came and published his first paper on photoelectric effect. So you know that this ball have mass and this ball also have mass, but do you really think that to displace this ball you need mass? Well, mass is not necessary. Suppose there's a speaker and you put some pieces of paper on the speaker and switched it on. You'll observe that the papers will start jumping off because of sound, and sound is an energy. That means you don't need mass to display something. You need energy. Even if you put two balls together without giving them some energy, without providing them with some kinetic energy, the ball will be at rest even though they have mass. So you need energy to display something. And according to Einstein, suppose instead of ball, on a surface you shine light. This is a photon, which is an energy packet, and on the surface there's an electron. So light with some energy will hit the electron, and this electron would get displaced with some kinetic energy. And now when this electron will get transferred or will get displaced, it will gain some kinetic energy, and this electron will then be called a photoelectron. Here the light is a wave, but here light now have mass, and this is what Einstein was telling, that light have both the properties. Light have properties of wave and the properties of mass. It have both the properties. So let's get over some mathematics. You need you know that energy is equals to h times nu, where h is the Planck constant times this nu, which is a Greek letter, which is basically the frequency, and this is the energy. So the energy of a photon is its Planck constant times its frequency. That means the energy of the photon is dependent upon its frequency, not the Planck constant, because it's inconstant. So the energy of a photon is based on its frequency. So you need some minimum energy to displace this electron, right? That means you need some minimum frequency with that photon to displace this electron, and this minimum frequency is known as threshold frequency and is denoted by nu naught. If energy is Planck constant times the frequency, then the minimum energy, which is denoted by psi, would be equals to Planck constant times the threshold frequency, and this psi is the work function. Now, as we know that if we want to calculate the kinetic energy of the photoelectron, we can say that it is equals to energy of the photon minus the threshold frequency. Hope it's clear. So we know that E is h nu, so we can write as K is equals to h nu minus this threshold frequency. And we also know that kinetic energy is half mv square. So if we want the maximum kinetic energy, that would be half times the mass of electron times v square max. Now now according to above equation, we can say that the kinetic energy, maximum kinetic energy, is equals to its frequency, its energy minus the minus the work function, which is the minimum energy, h nu naught. Now if we want an equation for this thing, h nu, that is the energy, I'm writing it here to save pages, we can say that h nu will be equals to h nu naught plus this k max. We know that k max is this thing here, so we can substitute its value, half mass of electron times the velocity squared max. And this is the equation for which Einstein got his Nobel Prize, and it says that light have the properties of wave and mass. Thank you.